Greetings to Dr. Muhammad Irman bin Ramli, our lecturer for BMMM 3583 Vibration Analysis and Monitoring. So, today we're going to present about our assignment, which is machine condition monitoring and fault diagnosis for bearing. So, the presenter is Piravin Tiran Analaki Sritaran B09 181 0023. Second one is Manmit Singh Analaki Gyansi B09 181 0480, and myself Anthony Blayong George B09 181 0068. So without further ado, we will present our topic for today.
I am Manmeet Singh. My ID number is B0918100480. I am from 3BMMM Section 2. Today I would like to give an introduction for our assignment, which is titled Machine Condition Monitoring and Fault Diagnosis, and our subtopic is bearing. Okay, as we all know, in a rotating machine, the rolling element bearings are the most important but also the most susceptible machine mechanical components. A bearing failure might result in a full machine failure, resulting in unplanned production interruption and financial losses. It's critical to have a good bearing condition monitoring and fault diagnostic system in place so that incipient bearing issues may be spotted and appropriately diagnosed early on before they worsen and cause machine damage. Early identification of a rolling element bearing fault in a high-speed railway or a wind turbine, for example, might lead to prompt maintenance or replacement, avoiding potentially devastating consequences and human loss caused by sudden failure or a vital mechanical component. The typical bearing fault frequencies are a starting point, but they are also the most basic information in bearing condition monitoring. When a bearing is operated at a given machine rotation speed under given loading circumstances, defects or faults existing in the bearing create the distinctive defect frequency component in a signal. Alternatively, throughout a bearing's operating life, fault signals might be created as a result of the natural wear process. Next, I will talk about the definition for the machine condition monitoring and fault diagnosis. It may be described as a technological field in which specified physical characteristics connected with machinery operations are monitored in order to determine equipment integrity. Next, the condition monitoring is the technique of continuously monitoring a machine's condition parameter, such as the vibration, the temperature, and etc., in order to detect a substantial change that indicates the onset of a malfunction. It is important part of a preventive maintenance. Thank you.
My name is Piravin Tiran Analaki Sritaran and my matrix number is B0918100023. I will be talking about how and the importance of bearing condition monitoring and the fault diagnosis is done. There are actually 5 usual condition monitoring techniques and fault diagnosis used for rolling element bearings. The 5 techniques are: number 1, ultrasound. In this condition monitoring, narrow band high frequency signals emitted by bearings are listened to and monitored to determine the changes in bearings condition through the sound levels of the bearing. Number 2, thermography. In this technique, thermo-infrared devices are used to measure the infrared energy emission from the bearing, where the heat variation of the bearing is monitored to determine the condition of the bearing. Next, number 3, which is vibration. The bearing vibration levels are monitored using an accelerometer, which is sent to a FFT analyzer, where the vibration levels are analyzed to determine the condition of the bearing. Number 4, oil and debris. This technique involves the process of analyzing the properties and particle contents of the lubrication on the bearing to determine the roller element bearings condition. Next, and finally, number 5, current signal. In this condition monitoring technique, variation in the stator current caused by change in the magnetic flux density between the stator and the rotor due to the induced current is monitored using a sensor to determine the condition of the bearing. Via the data collected through these 5 techniques, a maintenance personnel can determine the faults, defects, lubrication level, and wear that are present on the rolling element bearing. This process is called fault diagnosis. Next, now let's look at why is bearing condition monitoring and fault diagnosis is important. Bearing condition monitoring and fault diagnosis is important as it is able to improve a machine's uptime and efficiency while also cutting down machine breakdown time and maintenance costs significantly. It is also important to have an effective bearing condition monitoring and fault diagnosis as it enables beginnings of bearings faults to be detected early on and correctly diagnosed, which prevents the faults or defects from deteriorating further, causing a major breakdown or hazard to personnel. Bearing condition monitoring and fault diagnosis also aims to minimize production costs, optimize predictive maintenance, and also increase the machinery lifespan. Thank you.
Thus, as for conclusion, the usage for mechanical component demands a high maintenance and care. It is clearly and can be summarized that a rotating machine condition and well-being is determined by the state of its rolling element bearings. An efficient condition monitoring program for bearing operation can be used to increase the machine efficiency, save maintenance or any replacement costs, and extend the machine's lifespan, longevity, and perform in its top condition. Thus, in this report shows how the maintenance of the bearing can be done and why it is important in any industrial. Thus, here it can be concluded that monitoring can prevent accidents and may decrease personal and property loss. Besides that, if condition monitoring and fault diagnosis are not available in the early stage of the bearing damage development, it is difficult to avoid economic loss caused by suspending production necessary to ensure personal safety. Mostly of the machines have a long maintenance cycle, which can have a negative impact on production efficiency and earnings. And last but not least, it is very clearly stated and crucial that besides of the benefit in securing top-notch performance and longevity of the machine, it is also shows that monitoring can promote development of a more modern equipment manufacturing industry and enhance the commodity competitive power of major products and facilities. Besides, it also can be used as study from the fault information will be analyzed to determine the cause of failure and can give a feedback to manufacturers, allowing to improve the quality of products such as data bearing. Thank you.